Hello and welcome to all students. Now today in this lecture we learn about a scalar valued function and we study some new concept in this unit. So let us start our lecture now. So outline of our lecture is, first of all we see the definition of directional derivatives. Then we see some remarks and after that we see some examples. Okay, so let us start to define what is meant by directional derivatives. We know that we know that how to find the derivative, normal derivative, but we find or we studied how to find a derivative at a point. But now in this lecture we study how to find derivative in the direction, in the given direction, or derivative along the vector. Okay, so let us define. Let capital S be any non-empty subset of Rn, and let f from S to R be a scalar valued function. Okay, now what is meant by scalar valued function? That thing is known to you. Now let A belongs to S and U belongs to Rn be any vector, then directional derivative of f at the point A in the direction of U is defined as. Now that is very important. A belongs to A and U belongs to Rn, be any vector. The directional derivative of f at point A and in the direction of vector U is defined as. The definition is given here. How to write the directional derivative of a scalar valued function at a point in the given direction. दिलेल्या डायरेक्शन मध्ये तो डेरिव्हेटिव्ह कसा लिहायचा आहे याची डेफिनेशन इथे दिलेली आहे and there it is defined like this here, and it is defined as limit t tends to 0. लिमिट कोणाचा आहे बघा, f of a plus ut minus f of a divided by t. So this is the definition of directional derivative of a scalar valued function at a given point in the given direction. Okay, so definition is very much simple. Just we have to write the limit at t tends to 0 of f of a plus ut minus f of a divided by t. Okay, so to find directional derivative at a given point in the given direction, we have to find the value of this limit. We have to find the value of this limit. Okay, provided that this limit exists and is defined by du f of a, see here, d suffix u f of a or f dash a comma u. These are the two notations to denote directional derivative at a point in the direction of vector u. In the direction of vector u. So we write some remarks now. Our first remark is the directional derivative is given by the formula. The directional derivative is given by the formula. So that is the definition. Just du f of a is equal to limit as t tends to 0 of f of a plus ut minus f of a divided by t. So this is the formula to find directional derivative. We remember it, that is very important. And second remark is the directional derivatives studies the rate of change of a scalar field in a direction. Very important remark. It gives a physical significance of this directional derivative or geometrical meaning of this directional derivative. The directional derivative studies the rate of change of a scalar field in a direction. For example, consider a scalar valued function measuring the temperature of room at different point in the room. If we move in the direction of window, the temperature is different. If we move away from the window, the temperature is different. Therefore, direction play very important role when we measure the rate of change of scalar valued function. When we measure the rate of change of scalar valued function. Okay, that's why we study the directional derivatives. Okay, so let us take some examples based on directional derivatives. So one more remark is there. If u is equal to 0, then what is the directional derivative of scalar valued function f at point A in the direction of u? Just in the above formula we have to put u equal to 0. Then see what will happen. Limit t tends to 0, f of a plus 0 minus f of a divided by t is equal to 0. Means directional derivative become 0. So in the direction of 0 vector, the directional derivative is 0. That is very important. Okay, directional derivative is 0 in the direction of 0 vector, means no direction. Direction नसेल तर 0 येणार ना डेरिव्हेटिव्ह, because it is the directional derivative. Okay, now next remark is, if f is constant scalar valued function, if f is constant scalar valued function for any u belongs to Rn, then directional derivative of f at a in the direction of u is given by, this is the definition of direction derivative, is equal to limit t tends to 0, f of a plus ut minus f of a divided by t is equal to limit t tends to 0. As a function is constant, so for any input of an argument we get only c. As f is constant function, we put c minus c divided by t, so c minus c is 0, and that's why limit is 0. So for constant function also, the direction derivative in the given direction is 0 at a point. For constant function derivative is 0. Direction derivative, normal derivative सुद्धा 0 असतो आणि the direction derivative सुद्धा 0 होतो for a constant function. That is very much important. Okay, if f is a linear transformation, then for any u belongs to Rn, आता linear transformation म्हणजे काय ते तुमच्या लक्षात येईल आता. If f is a linear transformation, then what about its direction derivative in the given direction? Okay, so direction derivative of linear transformation f at point A in the direction of u is equal to limit f of a plus ut minus f of a divided by t tends to 0. It is the definition of direction derivative, and as f is a linear transformation, therefore f of a plus ut becomes f of a plus f of ut minus f of a is a as it is. So here f of a plus ut याचं कन्वर्जन f of a plus f of ut मध्ये झालेलं आहे, because f is a linear transformation. And in the next line we will cancel this f of a plus f of a with minus f of a. Okay, so cancel it, and what is left is limit t tends to 0 f of ut divided by t. So see here again f is a linear transformation, that's why. And uh, as far as function f is considered, t is constant for the function f, therefore we can take this t outside from the function. So in the next step we take t outside and we cancel this t with the t in the denominator. So what is left now? Limit t tends to 0 of f of u. But as far as this limit is concerned, f of u is constant thing. That's why limit of constant is that constant itself. That's why finally what we have, limit of f of u t tends to 0 and we get f of u. Okay, so if f is linear transformation, then its directional derivative at a point a in the given direction of u is f of u. Okay, so this is about the linear transformation of directional derivative of linear transformation f. Important. Now next, thus the directional derivative of f in the direction of u is the value of function f at point u. Okay, at point u असं म्हटलेलं आहे. Okay, so in the case of linear transformation, that is our conclusion. Now let us take some examples based on this directional derivative. First example is question number 1. Problems are there. Question number 1, find the directional derivative of function f of x comma y is equal to. Find the directional derivative of function f of x comma y equal to x square plus y square plus xy plus y at point 0 comma 0 in the direction of u equal to 1 comma 1. Okay, scalar valued function is given, point a is given, vector u is given, and we have to find the directional derivative of the function f at point 0 comma 0 in the direction of vector 1 comma 1 by using the definition of directional derivative. By using the definition of directional derivative. Okay, so answer here, a is equal to 0 comma 0, u is equal to 1 comma 1. We know the formula to find the directional derivative of function f at point a and in the direction of vector u. Here a is equal to 0 comma 0 and u is equal to 1 comma 1. Our formula is directional derivative of f at point a in the direction of u is equal to limit as t tends to 0 f of a plus ut minus f of a divided by t. So we put the values of value of vector u and point a. So here we put point a first. So du f of 0 comma 0 is equal to limit t tends to 0 f of 0 comma 0 plus 1 comma 1 into t minus f of 0 0 divided by t. So we solve this thing step by step. हा हे जो फंक्शन आहे एफ याच्यामध्ये 0 कॉमा 0 प्लस 1 कॉमा 1 इंटू टी लिहिलेला आहे, बरोबर आहे. तर तुम्ही यांची बेरीज जर केली व्यवस्थित से 1 कॉमा 1ला या टीनं मल्टिप्लाय करा म्हणजे तुम्हाला एफ ऑफ 0 कॉमा 0 प्लस टी कॉमा टी मायनस एफ ऑफ 0 0 डिवाइड बाय टी असं भेटेल. आणि 0 कॉमा 0 प्लस टी कॉमा टीची बेरीज करा, ह्याच्यामध्ये तुम्हाला एफ ऑफ टी कॉमा टी असं दिसेल. ओके, चेंज आपण फक्त तिथंच करतो आहे, कुठं फंक्शन एफमध्ये. आता फंक्शन एफची आर्ग्युमेंट काय झाली टी कॉमा टी, मायनस एफ ऑफ 0,0 आहेच. ओके, डिवाइड बाय टी. आता फंक्शन एफ ऑफ एक्स कॉमा वाय काय होतं ते आपण बघितलेलं आहे. ओके, फंक्शन एक्स कॉमा वाय. तसंच आपल्याला फंक्शन टी कॉमा टी लिहायचं आहे. फंक्शन एक्स एफ ऑफ एक्स कॉमा वाय हे तुम्हाला प्रॉब्लेममध्ये दिलेलं आहे. त्याच्यामध्ये एक्सच्या ऐवजी टी ठेवा, वायच्या ऐवजी टी ठेवा, म्हणजे तुम्हाला ते फंक्शन एफ ऑफ टी कॉमा टी लिहिता येईल. ओके, त्याच्यामुळे आपण एक्सच्या ऐवजी टी, वायच्या ऐवजी टी ठेवला तर इट बिकम्स टी स्क्वेअर प्लस टी इंटू टी प्लस टी मायनस 0 divided by t. Okay, now we simplify this numerator. It becomes 3t square plus t, 3t square plus t divided by t, and it is equal to limit 3t plus 1 as t tends to 0. 3t plus 1 as t tends to 0 म्हणजे टी टी कॅन्सल केलं बघा, एक 3t आणि प्लस 1 राहिला. So as t tends to 0, the answer will be, can you guess what will be the answer if I put t equal to 0 here? So answer will be 3 into 0 plus 1, and finally it becomes 1. So it is equal to 1. So in this way, the directional derivative of function f at point 0, 0 in the direction of vector 1, 1 is 1. Okay. Now consider the next question, second problem. Second problem is find the directional derivative of function f of x, y, z. Now the function is a function of three variables x, y, z, and that function is defined like this: xy plus yz plus z at point 0, 0, 0 in the direction of vector u equal to 1, -1, 1. जो आधी जो प्रॉब्लेम सॉल्व केला आपण त्याच पद्धतीनं हा प्रॉब्लेम सुद्धा आपल्याला सॉल्व करायचा आहे बाय यूजिंग फॉर्म्युला ऑफ डायरेक्शनल डेरिव्हेटिव्ह. ओके, तो फर्स्ट प्रॉब्लेम होता तो 2 डायमेन्शनलमध्ये होता. आता हा जो प्रॉब्लेम आहे तो 3 डायमेन्शनमध्ये आहे. 3 डायमेन्शनमध्ये 3 कॉम्पोनंट दिलेले आहेत. फंक्शन कसं डिफाईन केलेलं आहे ते बघा. एफ ऑफ एक्स, वाय, झेड इक्वल टू एक्स वाय प्लस वाय झेड प्लस झेड ॲट पॉईंट 0, 0, 0 and in the direction of vector u equal to 1, -1, 1. Answer here a is equal to 0, 0, 0. Point is given. U vector u is equal to 1, -1, 1. We know the formula to find the directional derivative of function f. We know the formula to find the directional derivative of function f at point A and in the direction of vector u. We know the formula to find the directional derivative of function f at point A in the direction of vector u. So what is that formula? That formula is du f of A is equal to limit t tends to 0 f of a plus ut minus f of a divided by t. This is the formula to find the directional derivative of function f at point A in the direction of u. Now consider the directional derivative of function f at point 0, 0, 0 in the direction of vector u. So once again, previously we have make this step. So limit t tends to 0 f of 0, 0, 0 plus 1, -1, 1 into t minus f of 0, 0, 0 divided by t. इथं आपण काय करूया, फंक्शनमधला जी आर्ग्युमेंट आहे ती सिम्प्लिफाय करू. अँड आफ्टर सिम्प्लिफिकेशन दिस आर्ग्युमेंट व्हॉट वी हॅव इज टीने वेक्टरला मल्टिप्लाय करा 1, -1, 1ला. इट बिकम्स t minus dt and that vector we add in the 0 vector. In the next step we get f of t minus t and minus f of 0 comma 0 comma 0 divided by t. Okay, now we have to find the two functional values. First is at point t minus t and second is at point 0 0 0. That function is known to us. What was that function? In that function, to find f of t minus tt, put x equal to t, y equal to minus t and z equal to t. Then and in to find functional value at point 0 0 0, so in the function f, put x y z 0, put x y z all these things 0 and see what we get. So in first case we get t minus t plus minus tt plus t and minus 0 divided by t. If we simplify this numerator, then what we have is minus limit t tends to 0 minus t square plus t divided by t. Divide by this t and what we have is minus 2t square plus t divided by t. Okay, so if we simplify this limit t tends to 0, then what we have is a limit t tends to 0 minus 2t plus 1. So again if I put t equal to 0, then we get the answer plus 1. So directional derivative of function f at point 0 0 0 in the direction of vector u is 1. Okay, so in this fashion we can solve the problems based on the directional derivative. Now consider, okay, see here, I have given one homework based on this lecture or based on the directional derivative. Try to solve this problem at your own at home, and if you find or if you find some difficulty, you can contact or can call me. Okay, uh, find the directional derivative of function f of x comma y is equal to x square plus 2y square at point 1 comma 2 in the direction of u vector u equal to minus 2 comma 3. And hint for this is use formula. हा का फॉर्म्युलाच वापरायचा आहे आपल्याला. डायरेक्शनल डेरिव्हेटिव्ह ऑफ फंक्शन एफ ॲट पॉईंट ए इन द डायरेक्शन ऑफ यू इज इक्वल टू लिमिट टी टेन्स टू 0 एफ ऑफ ए प्लस यू टी मायनस एफ ऑफ ए डिवाइडेड बाय टी. Problem is very simple. You can solve easily. Okay, so this is the end of our lecture now, and let us stop here. Okay, thank you very much.